Hello friends, welcome back. Hearty welcome to you. In the last session we have gone through formal definition of limit, and we also have seen example how to prove by delta epsilon method that a function is having limit at a as x tending towards a particular value. We have taken a linear polynomial as example. In this session we will take a quadratic polynomial as a function, and in the next session we will look into rational function. Now just let's have a recap and try to understand what is the formal definition of a limit. The formal definition of limit goes like this: given epsilon greater than 0, there exists a delta greater than 0 such that whenever 0 less than mod of x minus a less than delta, f of x minus L mod of f of x minus L will be less than epsilon. What's the meaning of that? The meaning of that is, if given that epsilon is greater than 0, there exists a delta greater than 0 such that if x is between a minus delta to a plus delta, then f of x will be between L minus epsilon to L plus epsilon. When we want to prove by delta epsilon approach, what we will do now is, we will take f of x minus L less than epsilon, we will take this and we will try to transform that into the form of x minus a less than delta, so that we can establish a relationship between epsilon and delta. Once we got the relationship, we will go ahead with the proof. We will say x minus a, let x minus a less than delta, then we will prove that f of x minus L is less than epsilon. So the formal definition is nothing but as x is between a minus delta and a plus delta, f of x will be L minus epsilon and L plus epsilon. If that is happening, then the function is said to be having a limit at as x is tending towards a, or at x equal to a, the function has a limit. Now let's take an example, quadratic polynomial, and try to see how we can solve that. So let's have a look at this example. F of x equal to x square plus x minus 2. We have to prove that limit of x square plus x minus 2 as x tends towards 2 is equal to 2. We have to prove this by delta epsilon approach. Now what is the first step we have to do? We have to establish a relationship between delta and epsilon. For that, what we will do? We will start from f of x minus L less than epsilon, that we will try to convert into x minus a is less than delta, so that we can establish relationship between delta and epsilon. Relation between delta and epsilon. So once we do that, then we'll go ahead with the proof. Before doing that, let's just try to plot this and see how this graph looks like. I have y equal to x square plus x minus 2. So can I write it as x plus 2 into x minus 1? You will agree with me that we can do that. Now x plus 2 into x minus 1, the y will be 0 whenever x is minus 2, that is here, and also at x equal to 1. That means these are, so you know that parabola will have the vertex in between these two, so it should be 1 plus 2, 3 by 2, that is nothing but 1.3 by 2 is 1.5, so I will be somewhere here in the 0.5. Okay, so let us say that. And another thing we know is that if x equal to 0, y equal to minus 2. So I know this point also, and also I know that somewhere here I will have my, somewhere here I should have my vertex. Let us say that that's how it looks like. Okay, so at x equal to 0, y equal to minus 2, And also we know that yet let us calculate this one also. We know 1 plus 2 1.5, that means x equal to minus 0.5, that will be 0.25 minus 2 minus 0.5, that is minus 2.25. so I should be somewhere below, because that should be where my vertex should be there. So let me just put it there. That's nothing but around minus 2.25. Let us say like that. Okay, now if I join this, let me just try to join this and make the curve. Okay, now we have got the graph. We can see that this is a function we have, y equal to x square plus x minus 2. At x equal to 0, y is minus 2, and it has intercepts at x equal to minus 2 and 1 with x axis. So this is how the graph looks like. So what we have been asked? We have been asked to prove that as you are tending towards 2, x is moving towards 4. That is what I have to prove. That means we have to prove that as x is moving towards 2, f of x should move towards 4. That is what we have to prove. Okay. For that, what we will do? We will start with f of x minus L, and we'll go ahead towards x minus L less than delta. Okay. Let's go ahead and do that. Okay. What is our f of x? Let's just keep it there. So I'll have f of x minus L is x square plus x minus 2, that is f of x, minus L, that is minus 4. I have to take less than epsilon, and I have to prove it. I have to transform that into the form of x minus L less than delta, so that I can establish a relation between delta and epsilon. Okay. Now you can see this is nothing but x square plus x minus 6 is less than epsilon, that is nothing but equal to x plus 3 into x minus 2 is less than epsilon. And now we are comfortable a little bit, because we are able to see x minus 2. This is nothing but, this is what we are interested in, x minus L less than delta. So only the problem is I have with this x plus 3. I don't know, I don't want other than x minus a less than some constant value. I don't want to have any other variable terms. That means I should find out its maximum value and should convert that into a constant. So this should be converted into a constant, or I have to find out its maximum value. To do that, what we will do? We will take a condition and we will say let delta less than or equal to 1. What is the meaning of that? The meaning of that is that we are limiting the delta to 1. That means a minus delta is 1, a is 2, a plus delta is limited to 3. That means whatever epsilon value you give, I will not deviate more than 1 from the a. That means I will not go outside 1 or outside 3. I will be between 1 and 3 only. So that is what we are saying. Let delta less than or equal to 1. Once we say delta less than or equal to 1, can I go ahead and say x minus 2 is less than delta, which is less than or equal to 1. Now what we are trying to do? We are trying to put a constant value, or we are trying to find out its maximum value. Now is this nothing but minus 1 less than x minus 2 less than 1? And what we want is, we want x plus 3 value. How I will get x minus 2? I have to add plus 5. So I will add plus 5. I will get 4. That will give me 4 less than x plus 3 less than 6. This is interesting. Now we got x plus 3 is less than 6. That means the max value x plus 3 can attain is less than 6. That means I can say that x plus 3 maximum value will be less than 6. I will leverage this now, and I will go back here and say, therefore x plus 3 I will write it as 6, and I will say less than epsilon. Now you can see that this is in the format what we need of x minus a less than epsilon by 6. This is nothing but x minus 2 less than delta. Both are equal. So we will establish the relationship delta equal to epsilon by 6. This will not satisfy all the conditions because we have taken one more condition. What is that condition? Delta is less than or equal to 1, based on which only we are able to attain that x plus 3 will not be more than 6. Now once we got it, so since I have to satisfy both of them, I know delta cannot be more than 1, but delta is also equal to epsilon by 6. So what I will do, I will write it as, therefore I will take both the conditions in one, saying that delta equal to minimum of 1 comma epsilon by 6. What is the meaning of that? The meaning of that is choose one of these two which is minimum value. If epsilon by 6 is less than 1, I am fine because my condition delta is less than 1 is satisfied. If epsilon by 6 is greater than 1, I will restrict delta to 1 because at any case delta cannot be greater than 1. So our approach will be, we will say delta equal to minimum of 1 comma epsilon by 6. Now let us take this condition and try to prove. Now this is the background work what we have done, and we have established the relationship that delta equal to minimum of 1 comma epsilon by 6. Now let's go ahead with the proof and utilize this condition. Now let's start the proof. We'll start the proof by saying, we'll say for every epsilon greater than 0, let delta equal to minimum of 1 comma epsilon by 6. And what we have to prove, if let us say that let 0 less than x minus 2, that is nothing but x minus a, less than delta. So what we have to prove now? We have to prove that f of x minus l, that is nothing but x square plus x minus 2 minus l, we have to prove this is less than epsilon. But we will see what is this. This is nothing but equal to x square plus x minus 6. This is nothing but equal to, we know already, this is x plus 3 into x minus 2. But we know a mod of x plus 3 is less than 6. So can I say less than 6 into mod of x minus 2? That I will write it as 6 into x minus 2 is less than delta. So I will say 6 into epsilon, let me say 6 into delta, that is nothing but equal to 6 into epsilon by 6. I'll just erase this so that this is clear. This is nothing but delta. 6 delta, 6 into epsilon by 6, that is less than epsilon. Now only the catch here is why we have written that instead of delta, how we have written epsilon by 6, because delta equal to minimum of 1 comma epsilon by 6. There are two criteria here. The first one is where delta equal to epsilon by 6. The second criteria is delta equal to 1. The first one, if you take, if delta equal to epsilon by 6, what is the meaning of that? So directly delta equal to epsilon by 6, then I can write in place of delta straightforward, I can say mod of x minus 2 is less than epsilon by 6. Because we have already taken let x minus 2 less than delta, and we are saying delta equal to epsilon by 6, therefore x minus 2 is less than epsilon by 6. If I take delta equal to 1, what is the meaning of that? The meaning of that is minimum of 1 comma epsilon by 6 is 1, that means epsilon by 6 is greater than 1. Or can I say epsilon by 6 is greater than delta? Or can I write it as x minus 2 is less than delta, but delta is less than epsilon by 6. So wherever I have delta, I can replace it with, for both the condition, with epsilon by 6. Let me repeat that again. When I say 6 into delta, you have 6 into x minus 2. You know that x minus 2 is less than delta, so we have replaced x minus 2 with delta. Now next, after that, we have replaced delta with epsilon by 6. Now how we can do that? We can do that because delta equal to minimum of 1 comma epsilon by 6. So delta can have two scenarios. One scenario, delta is equal to 1. If delta equal to 1, what happens? What is the meaning of that? Minimum of 1 comma epsilon by 6 is 1. That means epsilon by 6 is greater than 1. Are we saying epsilon by 6 is greater than delta, or delta is less than epsilon by 6? Therefore, I can say that instead of delta, I can write down epsilon by 6, which is a greater value than delta. In the first case, where minimum of 1 comma epsilon by 6 is epsilon by 6, I can straightforward go ahead and say delta equal to epsilon by 6. This is how we will prove it. Now what we will do, we will take some values for both the conditions whatever we are discussing here, where delta is epsilon by 6 or delta equal to 1. Let us check whether the proof satisfies or not. We will put some values for epsilon and delta, and we will see whether this is okay or not. Let us consider two cases. In the first case, we will take epsilon equal to, let us say we will take epsilon equal to 12. Okay, if epsilon equal to 12, what will be delta? Delta will be equal to minimum of 1 comma epsilon by 6, that is 12 by 6. 12 by 6 is 2. So minimum of 1 comma 2. Let me write it down here, that's better. I will write it down. Delta equal to minimum of 1 comma 12 by 6, that is 1 comma 2. Minimum of 1 comma 2, that's nothing but equal to minimum of 1 comma 2, which is nothing but equal to 1. So what we are saying, we are looking at the condition where epsilon is 12 comma delta equal to 1. Now let us see what we are saying now. We are saying that if x is between a minus delta and a plus delta, what are the values of x? Now a is equal to 2. We know delta, a minus delta is nothing but equal to x between a minus delta and a plus delta. What is the meaning of that? A minus delta is 1, a minus delta is 1, and a plus delta is 3. Okay, so 1 and 3, x between 1 and 3. What we want to prove? We have to prove that f of x between L minus epsilon and L plus epsilon. First let us check what is L minus epsilon, what is L plus epsilon. What is L minus epsilon, what is L plus epsilon. L minus epsilon, what is L? L is nothing but equal to 4. L minus epsilon, that is minus 8. L plus epsilon, that is nothing but 4 plus 12. L is 4, epsilon is 12, minus 8 and 16. Now let us check what is f of x. Let us check what is f of x. F of x is nothing but equal to, we have to check for any value between 1 and 3. Let us take the value 1.5. We want to check that at x equal to 1.5, which is between 1 and 3, that means a minus delta and a plus delta. Between a minus delta and a plus delta, f of x should be between minus 8 and 16. So let us check that. F of x is nothing but x square plus x minus 2. X square plus x minus 2, that is nothing but 1.5 whole square plus 1.5 minus 2, that is equal to 2.25, 3.75, 1.75. So you can see that f of x is between minus 8 and 16, which is nothing but equal to 1.75. Let's take one more example. We will take a case where epsilon is, let us say that instead of where we have now delta equal to 1, let us take delta equal to epsilon by 6. That means epsilon by 6 is less than 1, so that I can have delta equal to epsilon by 6. Let us have look at that particular. Let's look at case 2 now. Case 2 where we are saying delta equal to minimum of 1 comma epsilon is 3, so 3 by 6. So delta equal to minimum of 1 comma 0.5. So obviously delta will be equal to 0.5. So let us put down all the values. A equal to 2, delta equal to 0.5, and f of L is nothing but equal to 4, epsilon is equal to 3. So if I graph this, okay, delta is 0.5, that means where is, let us put it down, let us just plot it. So delta is 0.5, so I am here, delta is 0.5, that is 1.5, and another one is 2 plus 0.5, that means I will be going to here, 2 plus 0.5, that means it will be somewhere, I will be going to here, that is 2 plus 0.5, 2.5. So this is 1.5, this is 2.5. Okay, now this f of x, whatever you are getting, that means this should be between, let us see where is your L minus epsilon and L plus epsilon. Where is L? L is 4. 4 minus 3 is 1. So it should be between 1. Let me take another color. It should be between 1 and L plus epsilon. It should be between 1 and 7. Can you see that? The values are already between the whatever the range you want. We can also check it algebraically. We can check that way too. We will do that. Okay. So L minus epsilon. Let me put it down. What is A minus delta, A plus delta? I will say x between A minus delta 1.5 and 2.5. If proof is correct, f of x should be between L minus epsilon, that is nothing but 1 and 7. Let us check that. What is f of x? Let us take one value. Let us take one value x between 1.5 and 2.5. Let us take any one value. Which value we want to take? Now let us say f of 1.75. Okay, f of 1.75 will be something like here, almost here 1.75. You just draw that. That will be nothing but between your two boundaries of, this is L minus epsilon and this is L plus epsilon. You have L minus epsilon and L plus epsilon. Let us check this value and prove algebraically also. 1.75 whole square, that is x square, plus 1.75, that is x minus 2. So this is nothing but equal to 175 into 175, that will be nothing but equal to 3.0625 plus 1.75 minus 2. Whatever it is, we will approximately look at that. That is 3 minus 2 1, 1 plus 1.75, approximately 2.8. Now check whether 2.8 is between 1 and 7. Yes. So this proof what we have taken, that delta equal to minimum of 1 comma epsilon by 6 will take care of any epsilon you give. I am going to give you a delta such that if x is between a minus delta and a plus delta, then f of x is between L minus epsilon and L plus epsilon. We have seen this example in detail because I just want you to understand the background work, then how you have to give the proof. After that, how we can verify that our solution is correct by taking two cases of values. But when we do the next example, we will not do in detail like this. We'll just go ahead with the background work and we'll close it with the proof. So in the next session, we will go through a rational function and proving the same thing with delta epsilon approach. Thanks for your time. Bye for now.